So I'm Sarah Jean. I'm a graduate student in CurtisLab, and I'm going to talk to you about PeakSimple and GC. So PeakSimple is a software that we use to connect this GC to analyze the data. So right now we have a run. Well, first of all, let me back up. There is an SOP written called Using the GC Sarah Jean's Way. I highly recommend that you use that to understand a very basic setup for a simple injection. Rather than having a continuously fed sample. And so if you understand how to set it up this very simple way, you should be able to configure the GC in any way you want, because the whole purpose of this is to configure it for whatever your needs are. And so if you have headspace or some kind of gaseous space that you want to analyze, depending on how frequently you want to analyze it, you can connect it to this guy and the program and some kind of computer to analyze it in however way you want. And so first I want to focus your attention on the PeakSimple program. It is for Windows, so if you have a Mac like Declan or I have, you're going to want to either install something like Wineglass or Boot Camp so that you can run it, or any other program that will allow you to have multiple functionalities. And so right now Declan had just put in an excess of air into the sample loop, and so we're going to be looking for like 78% nitrogen, about 20% oxygen, and there should be very, very, very little CO2, so it should be negligible. And so you see here these red lines, this peak right here, this is the oxygen peak. We calibrated that and we named it oxygen 16 psi, whereas here we have nitrogen 16 psi, and then this is going to be called CO2 16 psi when it's finished running this full 13 minutes, which you can see in this corner here. When it's finished running this full minute, you'll see the whole spectrum. And so to give you an idea of how to navigate this, first of all, here it's the 0 to 13 that signifies the time. If you want to expand what you're seeing, you can press these buttons right here, or this button right here, and so then that moves this forward. And so instead of 0, now this is at 1, this is at 2, and so it just is scrolling. But it makes so you can have a wider range for what you're seeing depending on how your ramp time is. You want to go into, so we only are looking at 1 right now, and then if you go into this 1, 2, 3, 4, the channel button, you can take a look at all of these options. So the 1 signifies that we're working with channel 1, and so we only focus on this corner right here. The events it's what you're gonna tell the GC to do, and so it's going to tell you what the which valves should be on and on. And so the first thing you do at time 0 is 0 the instrument so that your peaks, the area under the peaks, can be more accurate. The G on is what rotates the valve, which we'll show you and explain later in the side of the actual GC. We 0 it again so that we know the data that's coming out later is going to be accurate, and then we switch it off at this time period that we've experimentally found to be appropriate, because we don't want CO2 in the instrument, and that's something we'll explain as we open up the instrument and take a look inside. The temperature profile, this is actually recommended, and so it should be linked in the SOP, it should be linked elsewhere in the Google Docs, and this is the suggested temperature profile for air, any kind of gas that you're looking for, CO2, nitrogen, or oxygen. And so we have it set up to run for 13 minutes. The reason that we have this particular timeline for 13 minutes is based off the flow rate that we have. Okay, so and so the flow rate is going to determine your events and your temperature profile, because the flow rate determines how fast the molecules go into the system. Your components are going to be manually entered each time, and so then these are our manually named and entered components, and that's for the calibration section of the SOP. Where if you right-click, you'll see that there's options to edit it. You can add a component, you can calibrate it, and there's a calibration folder in the Sarah Jean's GC folder, and so it just goes through, because notice how the Y-axis does not have units. The calibration is for your understanding of when you look at your results, so view results, even though this isn't done yet, it won't give us a correct reading, but your results would say you have a certain area percentage, or you have a certain area, you know, without units, and then you have to determine what those units are to use. So you could have it in volume, or you could have it in percentage. I choose to have it in percentage so that I could take different volume percentages of gas cylinders to correctly calibrate and understand what the area means. And so here I have it set up so that the area percentage is equal to the gas composition percentage. And it makes it really simple, the volume gas composition percentage. That makes it very easy to calibrate and understand the results. So one more thing. So this little green button means that it's running. It'll be red if it's disconnected to the computer, which means you need to be able to connect to the computer. And it'll be yellow when it's in standby or it's ready to run. And so when that's yellow, the instrument should also, the little button over here, should also be yellow. It's yellow when it's on and running, but it'll also be yellow when it's ready to run again. When the temperature, it'll be probably around 40 degrees Celsius. Right now it's at 185, which is really much warmer, and so after each run you have to wait for it to decrease in temperature. And then this will be off until it's reached the appropriate temperature. I think that's everything you need to know about peak. Well, one more thing maybe to talk about. It's not always clear how to connect your channel, and so obviously there's a USB connection between the GC, and it has the USB address 1574, and it connects to your computer clearly. You want to make sure that you are connected to that, which I believe is in details. No, is it? Maybe it is not in details. Channel. Nope, that's not right. Same thing. Maybe.
Is that in your startup document?
It's in the startup document.
Okay.
So we can maybe truncate this, sorry. I know where it is though. Overall. Oh, it's in overall. Is it still recording? Okay, yeah. It's in overall controls. And so this is the board type. I don't really want to click it or do anything. There are several options, but it's model 333. It's a 1-inch USB. And then this was the number that I read out loud, which is listed right underneath the USB. And then you don't have to worry about the rate really. This, don't touch that really. None of this really had to touch except for these two things, and then that should enable you to be able to connect. And that's right, yeah. And if you look, while we're looking at the side, this is also telling you, I mentioned earlier there's a flow rate. For this particular instrument at 27 psi, it's expected to go 20 milliliters per minute. You will see many different things on the internet that tell you many different flow rates for many different pressures that don't correlate to this. So if you're going to reference anything, do not reference from the internet, reference from the instrument, because this is correct. And some people who are even experts in this instrument, they will tell you that you're wrong for running it at this pressure, and they are the ones that are wrong.